Okay, we're going to jump into our next unit, which is a little bit more on derivatives. We're actually going to get into the application of derivatives. So there's going to be some more problem kind of stuff. So let's go ahead and get started. A little bit of a review to start with. First thing we're going to do is our review. If we kind of take a look at these, take the derivative of the following with respect to x, which is pretty much what we did. The derivative with respect to x of x cubed, we use the power rule, 3x squared. Now I'm going to tell you that we took the derivative with respect to x. So we actually took the derivative of x with respect to x. That's kind of what we did. But a number divided by itself, we kind of divide that out. This is just going to be 3x squared. We never really talked about that, but that's really what we're doing. And that's what the kind of the foundation of implicit differentiation. The next thing is going to be power rule, chain rule. So what ends up happening here is the 3 comes up front, x squared minus 5 squared. Then we need to do the derivative of what's inside, so that would be 2x. But again, this is with respect to x, so dx, dx. Those divide away, so this guy ends up becoming 6x, x squared minus 5 squared. So there's our first couple. Now we get one where we're going to take a derivative with respect to x, but we're using a y. So this is again now where we can actually start to apply the ideas of implicit differentiation. So if I use the power rule, this is going to be 3y squared, but then we're taking the derivative of y with respect to x. And that doesn't, so this actually is going to have a value, the derivative of y with respect to x. So we still need to take that derivative of y with respect to x. So that's kind of our foundation. For implicit differentiation, the whole point is we are taking everything with respect to x. Our goal is then to collect all the terms that are dy dx on one side, anything that's not dy dx on the other side. And then what we're going to do is we are going to basically solve for dy dx is what we do. So in this case, if I were to take the derivative of x squared, that is going to be 2x dx dx plus 3 dx dx minus 2y dy dx equals 0, and it's technically dx dx as well, technically. But notice these dx dx's all divide out to 1, so this just becomes 2x plus 3 minus 2y dy dx equals 0. And our goal is to get all of our dy dx is on one side, anything with a dy dx term-wise on one side, anything with that on the other. So what I'm going to do to make it easy is I'm going to move this over to the right side, 2y dy dx. And all I'm going to do here is I end up with 2x plus 3 equals 2y dy dx. And now what I do is I solve for dy dx. So what I'm going to do is I'm going to divide both sides by whatever is not dy dx. So we end up being dy dx equals 2x plus 3 over 2y. And the only thing you have to be aware of when you do this implicit differentiation is you need to make sure that the denominator doesn't equal 0. So this is going to be true as long as y doesn't equal 0. So what that basically means is if I want to take the derivative of this function with respect to x, I use x and y to figure out the derivative. I know it's a little weird, but you get used to as you do more of these examples. So again, we're going to take our derivative. So our derivative of y is going to be, in this case, we're going to have, dy dx equals 6x dx dx. Now here comes the deal. I need to use the product rule for this. U is going to be x, v is going to be y. So what we're going to find out is that u prime is going to be 1 dx dx. And this is going to be equal to 1 dy dx. Let's cancel out. So when I'm going for the product rule here, it's going to be uv prime. So it's going to be x times 1 dy dx. So it becomes x dy dx, because that's u v prime, u v prime, plus v u prime v, so that's going to be 1 times y, so that's going to be 1 plus y. Again, what ends up happening is we end up with, that cancels out as well. So that's going to give me dy dx equals 6x plus x dy dx plus y. And I want to get the dy dx's on one side. I want to get the non-dy dx's on the other side. So in this case, I'm going to subtract x dy dx. And I'm going to subtract x dy dx. And that's going to give me dy dx minus x dy dx equals 6x plus y. I want to factor out the dy dx here. And when I factor out the dy dx, I'm going to get 1 minus x, 6x plus y. And now here's the deal. I'm going to divide both sides by 1 minus x. So 1 minus x, 1 minus x. So I'm going to have over here the dy dx is going to equal 6x plus y over 1 minus x. And the only thing I want to say here is that x can't equal 1 because I can't make the denominator there 1. This is going to be the true derivative, the implicit derivative with respect to x, as long as x isn't 1. Okay. So again, just kind of follow through the process. X squared plus y squared equals 9. This is a circle centered at the origin with a radius of 3. That's what this, again, if you think about it, it's going to be this guy. So we're centered at the origin 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. What it's basically going to be is this. It's going to be that guy right there. That's the function. That's our function. It's a circle centered at 0, 0 with a radius of 3. Okay, so now what we're going to do is we're going to do our derivative. So this becomes 2x dx dx plus 2y dy dx is going to equal 0 dy dx, but it's just 0. We're going to cancel this out. What we want to do is we want to get the dy dx's on one side and the non-dy dx's on the other. So I'm sorry, this was dy dx. Sorry, I crossed off the wrong one. 2x. No, that's right. 2x dx dx, and this is 2y dy dx. That's dy dx. So that cancels out. So we're going to subtract 2x from both sides. 2x from both sides. We get 2y dy dx equals negative 2x. We're going to divide both sides by 2y. Cancel that out. That's going to give me dy dx equals negative x over y is really what it ends up simplifying to. And y can't be 0 for there. But here's what I want to tell you. If you actually go ahead and you take a look at this circle over here and you pick any point, you can figure out the slope. Because remember, this is slope. So let's talk about it. If I were to pick a point here, I have a positive x value in quadrant 1. I have a positive y value in quadrant 1. Positive over positive is positive with a negative in front. That tells me, hey, look, the slope there is negative. So the slope of a tangent anywhere in quadrant 1 is negative. Let's say I picked quadrant 3. Quadrant 3 down here, it's my x's are negative down here. So I have negative x's, I have negative y's, and negative divided by a negative is a positive. But that negative sign in front tells me quadrant 3 would give me negative slopes as well. And you could work the same kind of calculation here and here, where you have negative x's and positive y's. A negative divided by a positive is a negative times a negative is a positive slope. So that's kind of giving you an idea about the slopes. Okay. Last one, let's go ahead and do this. We got 2x dx dx. We're going to have to use the product rule again. So u is going to equal 5x. V is going to equal y. So u prime is going to be 5 dx dx. So it's just going to be 5. This guy over here is going to be v prime. Is going to be 1 dy dx. So then when we go to do this function, it's u v prime. So that's going to be 5x dy dx plus 5y. And that's technically dx dx. Dx dx. equals pi is a constant, the derivative of a constant is 0. Those divide out. So technically we don't need to write them down. I'm just showing you where they are. So this is 2x plus 5x dy dx plus 5y equals 0. And now what I want to do is I want to get everything dy dx on one side. I want to get everything, I dropped something. Oh, I forgot the y squared. I'm sorry. My mistake. Plus, forgot y squared. 2y dy dx equals 0. Forgot that. So plus 2y dy dx equals 0. So I'm going to get the dy dx stuff on one side. So that's this 5x dy dx plus 2y dy dx. This term and this term. And I'm going to get the other guys on the other side. So it's going to be negative 2x minus 5y. Subtract those from both sides. Factor out the dy dx. And we end up with 5x plus 2y equals, and I'm just going to do this just because I don't like having two negatives. Divide both sides by 5x plus 2y. 5x plus 2y. That's going to cancel out. That's going to leave me dy dx, or divide out to 1, is going to equal negative 2x plus 5y over 5x plus 2y. And what's going to make this denominator not equal to 0 is what we need to do is these two numbers can't be opposite of one another. So what I mean is 5x plus 2y can't equal 0. So I'm going to subtract 2y from both sides, 2y. And I'm going to have 5x equals negative 2y. Divide both sides by 5. And I'm going to say x can't equal negative 2/5 of y. So that's like a restriction because that would make the denominator 0. So that's implicit differentiation. That's kind of our examples. What I will do now is I'll go ahead and show you some word problems and how word problems work, or not necessarily like in terms of how you may see it. So the next piece we're going to look at is we have the equation x squared plus y squared equals 4. Find dy dx. So again, 2x dx dx, but remember the dx is canceled, plus 2y dy dx is going to equal 0. Technically dy dx, but like there's nothing there, so we're just going to leave it because anything times 0 is 0. So now what I'm going to do is get the dy dx's on the same side and the non-dy dx's on the other. So this becomes 2y dy dx equals negative 2x. Divide both sides by 2y. 2y, this is a repeat of what we did up front. Dy dx is going to equal negative x over y, as long as y doesn't equal 0. So let me go back and show the picture. If we look at this, describe where the derivative is positive, negative, 0, and undefined. So if we think about it, this is our circle again. So here is our circle. This one's going to be centered at 0 with a radius of 4. So it's going to be like 1, 2, 1, 2, 1, 2, 1, 2. We'll go ahead and draw ourselves a big old circle here. Not a great circle, but a circle nonetheless. Where is the derivative going to be positive? So if you want to think about derivative as slope, where are you going to have positive slopes? You're going to have positive slopes in quadrant 4. You're going to have positive slopes in quadrant 2. And the reason is because in quadrant 4, your x's are positive, your y's are negative. If you put a positive number over a negative number, you get a negative number. But then we have that negative sign in front of it. So a negative times a negative makes it positive. This guy's the same reason because x is negative and y is positive. We're going to get a negative over a positive, which again gives us a negative. The negative sign in front makes it positive. We have negative derivatives in quadrants 1 and quadrant 3 because x and y have the same sign, because x and y have the same sign. Okay, the next thing we want to look at is we want to look at where does it have a 0 slope. Remember, 0 slope, that means horizontal. Where does this guy have horizontal slopes? It's where x is 0 and x is 0. It's going to be this guy's 0 slopes are on the y-axis. In other words, anywhere here and there, you're going to have horizontal slopes. Okay. And the last one is undefined. Undefined is our vertical lines. The only place we're going to have our vertical lines is on the x-axis, where we'd have vertical. It's going to be, our slope is going to be undefined here, because our value in the denominator would be 0. That's 4. It's undefined. That's that one. Your area of a circle. So again, we're going to do it with respect to t. We don't always have to do it with respect to x. So this is going to be, if we take the derivative of a, we get dA dt, because it's a with respect to t, equals, pi is a constant. So what we can actually do is we can do 2 pi r dr dt. And there's our derivative with respect to a. And if you look at it, just as a hint, that right there, just as a reminder, that's circumference. So if you think about it, to figure out how the area changes of a circle, if we know how the circumference changes, it tells us how the area changes. Okay. Next one, we're going to do v equals s cubed dv dt. So we're going to take the derivative of v, which is 1, with the derivative of v with respect to t, equals 3s squared dv dt. That's right, not ds dt, sorry, ds dt. And if we look at this, we're already set up dv dt equals 3s squared ds dt. So this is the volume of a cube. And if you think about the volume of a cube, it's saying as the surface area changes, is like we take 3 of the sides and make them bigger. Think about a dice. We make 1, 2, and 3 sides, kind of like the 3 corner sides. So like here, here, and then kind of on the front side. It's going to make our cube bigger. So that's kind of the visual to think about. That's done. Now, this is probably the more akin to the kind of question you're going to see. What you're going to do is you're going to actually do your derivatives, and we're going to substitute in. So when we go to take the derivative of y with respect to t, or with respect to t, we're going to get the derivative of y is 1 dy dt. So the derivative of y. We're going to do our power rule, 4 times 3 x cubed dx dt plus 6 dx dt. So now what we're going to do is we need to figure out what is the value of dy dt, and it's given us all these things to plug in. So dy dt equals 12, 4 times 3, x cubed, x is 1, so 1 cubed. Dx dt is -3, because it's telling me dx dt is -3, plus 6 times -3. And if I went and I simplified this guy, I mean, I have our cube, kind of leave it that way, but if I simplified this guy, it's going to become -36 minus 18. This guy's answer is -54. 12 times 1 is 12. 12 times -3 is -36. 6 times -3 is -18. Okay. Last but not least, we're taking everything with respect to t. That's what it's saying. So the first piece is going to be 2x dx dt plus 2y dy dt equals 2z dz dt. And it's asking me to find this guy's value, which tells me they're going to give me answers for everything else, or the ability to find the answers for everything else. So this is going to be 2 times x, which is 3, times dx dt, which is -1. What is going to happen here is now we're going to do plus 2 times 4 times dy dt, which is what we're trying to solve for. So that's our unknown, equals 2. And I know that dz dt is 5. Well, here's the fun part. I can actually figure out what z equals. The reason I can figure out what z equals is because x squared plus y squared equals z squared. So 3 squared plus 4 squared equals z squared. That's 9 plus 16, so 25 equals z squared. So actually, I know that z is going to equal 5. Z times 5. Z is going to equal 5. It's a 3, 4, 5 kind of situation triangle. So technically, this is 5 as well. So now when I go to combine 2 times 3 times -1 is -6 plus 8 dy dt equals 2 times 5 is 10, 10 times 5 is 50. I'm going to add 6 to both sides. 8 dy dt equals 56. I'm going to divide both sides by 8, and I get dy dt equals 7. So I figured that out. It's a little bit of algebra. And that is really what we are talking about with this notes section. And then I gave you some homework questions, which are very similar. I believe you are going to have 4 just kind of simplified ones, and then 3 that are word problem-y that I'm going to ask you to do and have ready for Wednesday. Please come with questions. Otherwise, that is implicit differentiation.